Hello, everyone. I'm Annalea Beattie. I'm from Mars Society Australia. And today I'd like to talk to you about humans on a space science expedition in an analogue space environment in India, in similar conditions to those that you might find on other celestial bodies like Mars. So before I begin, I'd like to acknowledge the Big River tribe and all the Palawa peoples of Lutruwita, who are the traditional owners and custodians of the unceded land upon which I live and work. I acknowledge their sovereignty and I pay my respects to their elders past, present and emerging. I extend this respect to Aboriginal and Torres Strait Islanders from other communities. So thanks for coming, everyone. And thank you to the International Humans in Space Summit for putting this event on. Let's see if I can share my screen. Here we go. So if anyone's heard me speak before, you'll know that I'm an artist and I'm interested in the synergies between art and science. I use my art practice as a methodology for thinking about the future, about how humans will live and work together in enclosed environments in monotonous settings off Earth. So much of my work is conducted in extreme and hostile environments. And today I'm here to talk about one of those, a recent expedition, Amity University's Centre of Excellence in Astrobiology's second Earth and Space Exploration Program. I've just returned from India, where we completed 3 crew rotations in the high glacial deserts of Ladakh from July to the 10th to 22 to August the 7th. A diverse group of Earth and planetary scientists and engineers came together to work on understanding the changing ecosystems of Ladakh, as well as prepare for the exploration of other worlds. So I'd like to give some insight into our expedition into this extreme environment, as well as a brief idea of our program, an example of how science in the field really works, and I'll conclude by explaining a little bit about my role as artist on a space science team. So Ladakh is a very cold, high altitude desert region, 3,500 to 5,700 meters above sea level. It's located in the eastern part of the state of Jammu Kashmir in northern India. Its deserts offer a natural setting where a range of near pristine extreme environments can be accessed by vehicles within 2 days of the capital, Leh. Because of its high altitude, Ladakh has lower levels of oxygen in its atmosphere and high levels of UV radiation. It usually receives little rainfall and it experiences large fluctuations in temperature between day and night and between seasons. Ladakh's glacial deposits and regions, dunes and intra-dune ponds, hot springs, saline lakes, and permafrost regions are high altitude environments for off-Earth analogue and astrobiology research. On our journey up into the Himalayan mountains, our ESP explored field sites that might help us understand the past of our planet, the evolution of life, the effects of climate change, and how we might train for the exploration of Moon and Mars. In this hostile environment, breathlessness and ataxia are common, and it was often difficult to move around. Our expedition carried oxygen tanks, and we travelled with a doctor. You probably know astrobiologists use analogue research to explore the terrestrial, to understand something of the extraterrestrial. In this case, in Ladakh, our Earth space exploration program explored and examined sites of astrobiological significance to compare Earth to Mars. Our aims were to bridge between education and research, to understand the conditions under which life can arise, how we might look for habitable worlds, and how to search for the evidence of life. So here we have our geologist on the first crew rotation, Dr. Amir Khan, showing us his modelling skills, how the Himalayas are formed. Our key field sites in Ladakh included Somari, Sokar, hot springs within the Puga Formation, and a visit to Hanli at 4,500 metres, set in India's first dark sky reserve. So this is a broad introduction to the terrain. And now I'd like to share with you one example of a great science day in the field to try and demonstrate how our space exploration program actually works. I'm going to use sedimentologist Sally Potter-McIntyre's field trip to the hypersaline lake Sokar as an example of how fieldwork in this context can be used not only for scientific research, but for educational purposes. So terrestrial studies of hypersaline and saline lakes inform our knowledge of how saline lakes may have existed on early Mars. Sally Potter-McIntyre is a scientist from South Illinois University, and she joined our science team on its third and final rotation into the Himalayas. Sally's research aims to test the hypothesis that subsurface biogeochemistry can be derived from surface and near surface, 10 to 20 centimetres in depth, precipitates. This is especially meaningful for the search for life on Mars because the subsurface would be the longest lived habitat and possibly even an extant one on Mars. At putative Martian springs, all that remains of the subsurface are the superficial spring deposits. So a comparison of fluid precipitates furthers our understanding of relationships between reservoir fluid biogeochemistry and the resulting precipitates on Earth, and may directly be applicable to investigations of putative spring systems on Mars. So the night before our field trip to Sokar, Sally Potter-McIntyre assembles her crew for field work. This is her focus overall: to observe and describe the site, measure the water, collect water samples, collect soil samples, and to get samples ready for the lab. Pairing geologists and non-geologists, Sally split our crew into smaller teams, nominating group leaders and outlining tasks to be shared amongst each group. Then she trained each group with everyone listening. For instance, the coring team trained in how to decide core sediment sampling at regular distances on the shoreline, how to geotag their location, how to take the samples gently pounding the soil, core barrel into the soil at about 10 centimetres depth, how to remove the sample, wrap it in tinfoil, mark it at the top, and name it and label it according to Sally's own classification system, and then carefully pack it away for transport. So the next day we travelled to Sokar in the Rupshu Plateau. Sokar is a wildlife sanctuary. The lake is situated at 4,657 metres, about 15,300 feet. On arrival, Sally and her team surveyed the site and took descriptive notes and decided upon directions. We all broke up into groups to survey and sweep the modern shoreline, sampling unique and representative rocks and using our core sediment sampling techniques. While everyone set off to complete the fieldwork, Sally, as lead scientist, traced the paleo shoreline with a smaller group. 2 hours later, all the tasks that Sally had set for us were complete, and 2 hours in that high UV and low atmosphere was enough for all of us. We returned to camp elated to discuss our findings. In that short, intense period of time, crew 3 had successfully worked together to finish all their tasks. Sally had supported us to bridge between the goals of her analogue research and our science education. The point is that through process-based learning, critical inquiry, and teamwork, Sally Potter McIntyre helped us understand some of the complexity of this extreme lake habitat. And within the framework of astrobiological research in field science, everyone in our crew now recognise through practical experience and collaboration how SOCAR, as a terrestrial analogue for planets like Mars, can really help us find out more about Earth and Mars, as well as prepare the explorers and scientists of tomorrow. As an artist, I'm always interested in practicalities, collaboration, the materials, process, and hands-on experience. I have a motive. I always think a lot about how, as humans, we might live together in the future on another planet, and what exploratory role art making, the materiality of art, might have in a monotonous, routine-driven environment where failure is not an option. Working in a team in an analogue environment, as we did in SOCAR, makes me think about things like this. So what's become apparent to me to work in science is I've had to become very interdisciplinary in my approach to art making. Consequently, I'm a science generalist, and I changed my role in any way at all to situate the techniques, processes, and the experiences of making art as alternative knowledge in the work of others, and within disciplines and in landscapes not usually conducive to art making. So on every space science expedition, my roles change and overlap and blur and blend. But as an artist, this means a socially engaged practice where collaboration is key. Listening to the voice of others is important. And in this context, my art practice follows as much as it leads, improvises and adapts to find a position within the goals of science. So in Ladakh, I tried to find a particular art-making role in order to collaborate with scientists. On our second crew, I worked at one pristine alkaline hot spring in the Puga Formation as field artist, where I sketched the geology as the context for the sampling work of Laura Sanchez Garcia from the Institute of Astrobiology in Madrid. Laura's research aims to learn about the limits of life, the ecology inhabiting this extreme environment with the interest for early life, and what type of biosignatures to search for in analogous hydrothermal deposits on Mars. My aim as an artist was to keep up with her data and then construct an artwork from the field sketches that worked for me as an artwork and worked for her as an astrobiological journal figure drawing. I'm just getting started on that field drawing this week. It could end up being a painting. So another way to, on our ESCP, another way to situate art making and find commonalities with science is drawing rocks that are similar to those that we might find on Mars. So I might facilitate our participants on the trip to work with the geologists, finding them drawing the rocks, and then highlighting observation as a key skill set for planetary field science. Or I might invite our participants to draw the night sky at Hunley at 4,500 metres, 14,763 feet. At the highest dark sky reserve in India, we draw the hue of the sky as much as the magnitude of the stars it contains. Then we used a scientific scale to measure visual acuity, trying to understand the amount of zodiacal light in the sky. On crew one, on our student rotation, I supported a zoology student, a web designer, and an artist in an art-based project which culminated in an outdoor art exhibition at the same dark sky reserve, high on a hill at 4,500 metres. These three students, including my daughter Mona, explored the shared gaze, painted on rocks, held artist talks, read their own poetry, and took questions from the crowd in what must be the highest art exhibition in the world. We're in the camps at night. I work with microbiologists to draw hyperthermophiles, Haliarchaea, and polyextremophiles through the microscope. This time on our ESCP Ladakh, I invited all our participants to find new imaginative ways of working, encouraging them to journal and sketch daily, to write and draw nature, its past, present, and future, and with the Amity and Earth Space Exploration Program, creative nonfiction anthology, drawn by scientists and technologists. This anthology of images and text will explore something different about our experiences in the glacial deserts of Ladakh. So I've explained that as my second role as researcher, I try to embed art making on space science trips to understand through practice and community engagement what kind of roles artists might have off Earth in the future. I'm part of a group from the UK Centre of Astrobiology and the British Interplanetary Society that publish writing about challenges for off Earth, and we're up to our 4th book. So, by the way, I'm not really a field artist. Usually my research will come from field work, but in actual fact, you know, I have to, I'm pretending to be a field artist, but I'm always very attentive to the kinds of sensory deprivation that occurs in extreme environments or within the constraints of simulation. As educator and science communicator on our ASCP, I teach thinking through drawing in the field, face-to-face as well as online in Amity Astrobiology courses and in workshops. After our expedition to Ladakh, we held a 2-day astrobiology workshop in Mumbai. Often online, our faculty works with enormous numbers of participants. The last time there were 750 in the group from 53 countries, and we made a book of drawings and text about developing a draft constitution for off-Earth settlement. As adjunct professor in the faculty of the Centre of Excellence in Astrobiology, I'm always a mentor for undergrads, especially in relation to furthering career paths in astrobiology. For instance, here's our new Women in Space India group, which we formed at Annalea, and the whole of Prutu joined. Opportunity creation as part of this work. My final role is of senior expeditioner with the goal of sharing my experiences of analogue studies in extreme environments. I'm a member of the Association of Mars Explorers, as I've spent some time working on space science field trips in environments that have similar conditions to those you might find on other planets. So whether we're traveling to the hot, dry deserts of Utah, or down in the deepest, darkest mines of Bulbi, or to India, to Lona Crater as an amazing basalt analogue for Jezero on Mars, or to Australia, where Mars Society Australia are planning to build a Mars Science Desert Research Station. There's a lot we can learn about living on other planets from analogue environments. So back to Ladakh. I hope you know a little bit more now about our Amity University Earth Space Exploration Program and its interdisciplinary nature. If you're interested in astrobiology and would like to join us next year, please let me know. For myself, I really would go to Mars if I was offered the trip. Humans will be living in space in the near future. So all I want to do is be a participant, have a voice, and make sure that artists are part of building rich communities and cultures off Earth. Thanks for listening, everyone. You can contact me at annalea.beattie@rit.edu.au. Thanks again. Bye.